I'm going to talk about converting between polar and rectangular coordinates. I'll assume that you're familiar with polar and rectangular coordinates. If you're not, I would recommend you first watch the necessary videos. All right? So give me a minute now to draw a picture. All right, so there's a picture of an XY coordinate plane. Now, to show how the polar coordinates r and theta are related to the rectangular coordinates x and y, it'll help to analyze a right triangle that corresponds to a point on the xy plane. Let me denote a point by a green dot, okay? And so we know that position, the position of that green dot, can be described by some values of x and y in rectangular coordinates and some values of r and theta in polar coordinates, right? Now, watch how those variables are related to the following triangle. So if I draw a triangle, a right triangle, such that the legs are parallel to the xy axes and the hypotenuse has an endpoint at the origin and the other endpoint at the location of the green dot, then for that right triangle, the length of the hypotenuse will be r, the length of the horizontal leg will be x, the length of the vertical leg will be y, and the measure of the angle between the hypotenuse and the x-axis will be theta. All right? Now, to see how r and theta are related to x and y and vice versa, let's use the definition of cosine and sine. Okay? What is the cosine of theta in terms of the lengths of the sides of that right triangle? Isn't it x over r? And what about sine of theta with respect to the lengths of the sides of that right triangle? Isn't the sine of theta equal to y over r? All right? So now, multiplying both sides of those two equations by r, we can see that we get x is equal to r cosine of theta and y is equal to r sine of theta. So that's how you convert from polar coordinates to rectangular coordinates. All right? What about converting from rectangular coordinates to polar coordinates? Well, do you agree that the Pythagorean theorem applies to the right triangle? In other words, doesn't x squared plus y squared equal r squared? So that means that r must equal the square root of x squared plus y squared, right? And furthermore, we can describe the tangent of theta in terms of the lengths of the sides of the triangle, and that'll give us y over x. Okay, so from that we can determine what theta is in terms of x and y. Okay, So that's how we convert between rectangular coordinates, or go from rectangular coordinates to polar coordinates. Let me issue one warning. So the arctangent of y over x, that will work beautifully as long as x is greater than 0. If x is less than 0, you will have to add pi to the arctangent if you're working in radians, or 180 degrees if you're working in degrees. All right? That's because the range of the arctangent only includes acute angle measures. So if theta is bigger than 90 degrees or bigger than pi over 2 radians, you're going to have trouble. Okay, so keep that in mind. You'll also have trouble if theta is negative. All right, negative and bigger than or smaller than minus pi over 2. Okay, now let's use these conversions to these conversion equations to do some exercises. So let's convert this set of coordinates, set of rectangular coordinates to polar coordinates. So we can get r from the equation based on the Pythagorean theorem. So that will give us 5. And the theta will be the measure of an acute angle. So we can use the arctangent of 4 over 3. Okay, and so expressed in polar coordinates, we have 5 comma the arctangent of 4 over 3. Or if you want a decimal approximation. So that is the correct answer, but you can also say 5 comma 53.13 degrees approximately. Okay? So that's converting from rectangular to polar. What if we wanted to convert from this set of polar coordinates to rectangular? Well, x, using our conversion equation, x is equal to 4 cosine of pi over 3. That gives 4 times 1/2, which is 2. Y is equal to 4 sine of pi over 3. That gives 4 times root 3 over 2, which is 2 root 3. So putting it all together, expressed in rectangular coordinates, we have 2 comma 2 root 3. All right? Now I'd like you to do some examples. Would you please convert 0 comma 2 to polar? All right? What is that in polar? So pause the video and do that now if you like. All right, so I'll go ahead and do it as well. So it's going to be a point located on the y-axis. Okay, the distance from the origin is going to be 2. So r is 2. You can also determine that from the square root of 2 squared. All right, we don't need to worry about the 0 in calculating r. And then, because it's on the y-axis, located above the origin, theta is going to be pi over 2. We can determine that from noticing that 2 over 0 is undefined. So putting it all together, 2 comma pi over 2. Okay? Now let's try an example of converting to rectangular coordinates. can you convert 1 comma minus pi over 3 radians to rectangular coordinates? So pause the video and do that one now, please. Okay, so I'll go ahead and do it as well. So x is going to be the cosine of minus pi over 3, which is equal to the cosine of positive pi over 3, which is equal to 1/2. Y is equal to the sine of minus pi over 3, which is equal to minus the sine of pi over 3, which is minus root 3 over 2. So the answer is 1/2 comma minus root 3 over 2. Okay, now let me talk about something related. Not only can we convert points from one coordinate system to another coordinate system, we can also convert functions and equations from one coordinate system to another coordinate system. Okay? Let me show you some examples. Suppose I had the polar equation r equals 3 cosine of theta. So to find the equivalent equation with respect to rectangular coordinates, we could just use the equivalent expressions in rectangular coordinates. So r is equal to the square root of x squared plus y squared, and theta, if theta was, at least if it was an acute angle, it would be equal to the arctangent of y over x. Okay? So there you have it. There is the equivalent equation in rectangular coordinates, at least for acute angles theta. Now, there's some work you can do to try to simplify that equation, okay, but that does meet the requirements. Nevertheless, let me show you how you can find a simpler equivalent representation. So the cosine of theta is equal to x over r. So the original equation is equivalent to r is equal to 3 times x over r. And so that is equivalent to, if I multiply both sides by r, 3x equals r squared, or 3x equals x squared plus y squared. Okay? And so the best I can do is x squared plus y squared. If I subtract 3x from both sides, I get that. Okay? So that's the equivalent expression with respect, equivalent equation with respect to rectangular coordinates, as nice as I can make it. Okay? What about if I had an equation in rectangular coordinates? Can I convert it to polar coordinates? Let's start with x squared plus y squared equals 1. So that's a circle centered at the origin, the graph, the corresponding graph, with a radius of 1. Okay? So that might immediately allow you to see that the answer is going to be r equal to 1. If you didn't see that, you can just substitute for x r cosine of theta, and for y r sine of theta. Okay, and if from there you can factor out the r squared, Okay, and then if you notice that in the parentheses we have the Pythagorean identity, and we know that we have the expression that's equal to 1 with respect to the Pythagorean identity, so we can ignore that. So r squared is equal to 1, or r is equal to 1. Now, you could have r is equal to minus 1, but that would give the same graph. So we'll just pick the positive number. Okay? Now, let's do some related examples. Can you find the polar representation of the equation of a parabola? Okay, y equals x squared is a parabola with its minimum at the origin. So maybe you're curious what the parabola equation, corresponding parabola equation, looks like in polar coordinates. Can you find it? So pause the video and try to do that now, please. Okay, I'll go ahead and work it out as well. So y is equal to r sine theta. X is equal to r cosine theta. So I'll use those for the necessary substitutions. Now I have r sine theta equals r squared cosine squared theta. I can divide both sides by r, and I can divide both sides. Well, let me divide by cosine squared theta. So I have r is equal to sine theta over cosine squared theta. If you like, you can write that as sine theta over cosine theta multiplied by 1 over cosine theta. So probably the nicest that I can present the answer is r is equal to the secant of theta multiplied by the tangent of theta. All right. What about this equation, xy equals 1? Can you convert that into the equivalent polar representation? So pause the video and do that now, please. Okay, so I'll go ahead and do that as well. So r cosine of theta times r sine of theta, just using the conversion expressions. So that gives r squared times sine theta times cosine theta equals 1. So r squared equals 1, I'll write it this way, 1 over sine theta multiplied by 1 over the cosine of theta. Now I can take the square root of both sides, and the nicest I can probably write it is the following. R is equal to the square root of the secant of theta times the cosecant of theta. Okay? Now I'd like to close with a little more involved one. Can you convert the following polar equation to the corresponding rectangular equation? R equals 3 sine theta tangent of theta. So try that one now. Pause the video and do that one now if you like. Okay, I'll go ahead and do it as well. So first, let me do the substitutions only for the right side. So the sine of theta is equal to y over r. The tangent of theta is equal to y over x. So let me multiply both sides by r. So I get r squared equals 3 times y squared over x. And I know that r squared is equal to x squared plus y squared. And I could multiply everything by x, and that'll give me 3y squared equals x cubed plus xy squared. So the nicest that I can present that is probably the following. X cubed plus xy squared minus 3y squared equals 0. All right.